Now, some of you may find doing the long division to find the rest of the factors can be rather tedious. Well, I think so too. Okay, so is there any better way to do the long division without really doing the long division? Okay, so there is one, and this is called the synthetic division. The synthetic division is in essence a shortcut to the long division. Okay, so let's get started. How are we going to do the division of x cubed minus 7x plus 6 being divided by x minus 1? So how are we going to do this division without doing the long division? Okay, here's how. For doing the synthetic division, there are a few things you have to take note of. Okay, the first thing is you always look out for the highest power of the dividend. So this is the highest power, which is x cubed. So you put down x cubed. Okay, and you go by descending order of the power. So the next one will be x squared, followed by x, and after x will be a constant. Okay, so what you do next is you write down the coefficient of the x cubed, the x squared, and the x. Okay, now you may notice that there's no x squared here, but you still have to put in an x squared. It has to be in descending order like this: 3, power 3, power 2, power 1, and then power 0 eventually. Alright, so now let us write down the coefficients. The coefficient of x cubed will be 1, so 1 here. Coefficient of x squared, since there's no x squared, so the coefficient of x squared will be a 0. And coefficient of x will be negative 7. Well, the constant itself is 6 positive. So now after you write down the coefficient, you put a plus here and you draw a line across. Okay, and now draw one little box here. This little box is for the divisor. So the divisor is x minus 1. The x value will be a positive 1. Okay, so you put a positive 1 here. Alright, so this is the so-called the stage for your synthetic division. Okay, so you haven't really done any division yet. All you have done is just to set up the stage to do the division, to perform the division. So how are we going to do that? Well, pay attention to this. First step, you bring down the 1. Okay, bring down here 1. Okay, and you take this 1, multiply by this number here, which is so happen to be another 1. So 1 multiplied by 1, you get 1. And you, what do you do with that 1? The product, you put it here, 1. Okay, and then you add, since this is an add here, so you add 0 plus 1, you get 1 again. Alright, now, and then you take this answer, multiply by this number again, and then you put here, so you get 1 multiplied by 1, you get here again. So minus 7 plus 1 will give you a negative 6. So negative 6 multiplied by 1 will give you another negative 6. So 6 minus 6 will give you a 0. And, well, you have more or less finished the division. Okay, but of course, let me explain. Now, this 0 here, okay, this position here, this place here, is for the remainder. So if you get 0, well, it goes to confirm one thing, that the x minus 1 is indeed a factor. Now, if you don't get a 0 in a synthetic division, alright, you will know, well, something is wrong, isn't it? Okay, something is wrong. It's either that x minus 1 is not a factor, which in our case here can't be the case because it is given to us x minus 1 is the factor. So the second possibility that if you don't get 0 here would be you have done your division wrongly. So I suppose this is a lot easier to check, okay, to check your mistake than when you perform your long division and then you don't get a 0 as the remainder eventually. Okay, that would be a lot more time consuming to check. Alright, so now then you may ask, okay, so you say that this is the long division and where's the product? Okay, unlike the long division, you really can see the product, the quotient, right? I mean, you can see the factor, the quotient. In this case, where's the quotient? Okay, so this is how we decipher the synthetic division, the result. Okay, now this 1 here, okay, we have to move 1 degree lower. So this 1, okay, can no longer be the coefficient of x cubed, isn't it? So this 1 will have to be the coefficient of the x square. So move 1 degree lower. So it's 1x square. Okay, this 1 will be 1x. So it's positive x. And this 6 will be this constant. So it's negative 6. So this will be the quotient. Okay? Which means that when you take x cubed minus 7x plus 6 divided by x minus 1, you will get a quotient of x squared plus x minus 6. Okay, this is precisely what we got when we did the long division earlier on. Let's bring back the long division working that we did earlier on to have a look. This is x squared plus x minus 6. Now, here we go. This was the previous long division that we did for the same question, okay, the other method. So as you can see, the working of this long division, okay, we get the same quotient, you see, x squared plus x minus 6. So of course, obviously you can make a very quick comparison between this working and this synthetic division working that we see here. Okay, which is the one that you think is easier? I mean, of course it's this one, isn't it? I mean, it's so easy to just bring down, multiply, put here, bring down, multiply. But of course this comes with a little bit of practice because it is not as common as the long division. Okay, because we have been playing around with the long division since primary school, so that may appear to be more familiar. Okay, nevertheless, it is a shortcut. Okay, there are some restrictions to a shortcut all the time, so we'll talk about that later on. So now we have basically gotten the product, okay, the factors, the other factor. Okay, so we know that x minus 1 is the factors, and therefore the other factor is x squared plus x minus 6. Okay, but of course this is not completely factorized because x squared plus x minus 6 can be factorized further, and that will give us an x minus 2 and x plus 3. Okay, so and by this, well, we have completely factorized our function. Okay, our x cubed minus 7x plus 6. Okay, now, so does it mean that now that you have learned synthetic division, you can totally forget about the long division? Well, that's not true. Okay, the long division is still important. Okay, you will need to know how to perform the long division for the fact that some of the time you may need the remainder. Okay, some of the time you may need the quotient and the remainder at the same time, so you need the long division. You will need to do most of the long division when you are doing partial fractions. Okay, the topic of partial fractions. So always remember, synthetic division is just a shortcut to the long division. Okay, it's not a replacement. Alright, so I'll prepare a few more synthetic division examples so that you can try to get a hang of it.